Hi, first of all, I welcome you to Organic Chemistry with Dr. Naveed Iqbal. Today we will be discussing azimuthal quantum number. That what information does this azimuthal quantum number give to us? So previously the principal quantum number, it gave us the information about the shells. It was talking about the shell, and it gave us some numbers just like 1, 2, 3, 4. 1 was K shell, 2 was assigned L shell, 3 was assigned M shell, etc., etc. So that was talking about the shells or energy. And now the azimuthal quantum number L, what it talks about, it just give us information about the shape. How it gives us information about the shape? It just specify us that in how many shapes are present in one shell. You will understand it a little bit later when I'll be explaining it. So it is again a quantum number, so it again will give us some numbers. So it's give us the numbers just like L could be equal to 0, 1, 2, 3, etc., etc. So there is an, as I told you, it give us information about the shape. So when L is equal to 0, it is S, spherical shape, or S orbital or spherical shape. When L is equal to 1, it's dumbbell. When S is equal to 2, it's double dumbbell. When S is equal to 3, it is a complex or sausage type of complex shape. So let me draw some orbitals for you, as it is a course designed for the beginners. So S orbital is just like this sphere, but it's just a circle. It's not a sphere because a sphere is in 3 dimensions, just like an orange, etc. Lemon, orange, those are in 3 dimensions. So it's just a ball. P orbital is again like this. It's again like 2 balls, a little bit oblong balls, present, and there is a little bit a small distance in between them, a vacant space. So these are 2 balls about touching each other, very near each other, but there is a vacant space in between them. And sometimes, and mostly you people have seen that one is shaded, or one lobe of this p orbital is either shaded or it is described by plus, or the other is described by negative, or shaded or unshaded. Those they are just telling about the sign of the wave function, but that's beyond the scope of this course. We would be discussing it in the advanced course. If anyone would like to study that, they can just watch the video on my videos on the advanced course, and you will find it. Another orbital is called D. D is just like this. So it's 2 oblong balls like this, just touching each other, and 2 oblong balls like this, just touching each other, but there is a small space in between them. They are just not exactly touching each other, just like this. So it's like 2 p orbitals, one like this and the other like this, and these are the phases of the p orbital. Now let me tell you that how this principal quantum number, azimuthal quantum number relates with the principal quantum number. What is their relation? Just like I was talking about, if you want to find a person in a city, so you go and first you find the name of the city, then go to the street. So what information this azimuthal quantum number give us, and how it is related to the principal quantum number that we are now going to find the block. So L is equal to n minus 1, 0 up to n minus 1. It's just not n minus 1. It's 0 up to n minus 1. It will be clear from some example to you. Just if principal quantum number is n is equal to 1, so we are talking about K shell. So what would be the value of L for it? L would be equal to 0 up to n minus 1, or n is equal to 1, So 0 answer is, and here's 1 minus 1 is equal to 0, so it would be 0. And you know that 0 is assigned to S. 0 tells us that it is S orbital or sphere, so it tells us about the S orbital. But which S orbital it is a lowercase s. Which S orbital it is? So we'd go from here, n value will give us that which orbital it is. So n is equal to 1, so we have to put it like this. It is talking about 1s, so the K shell has just one shape into it, and this is sphere. Now if n is equal to 2, n is equal to 2, so L is equal to 0 up to n minus 1, 0 minus 2 minus 1, 0 and 1. So it is talking about S and P. But which S or which P? So as n is equal to 2, it's the L shell, and n is equal to 2, so you have to place or put the 2 before the S to make it clear that which principle, which shell we are talking about. So the L shell has two shapes into it. It has one sphere and a dumbbell. Now if n is equal to 3, you can calculate by yourself. N is equal to 3, so L is equal to 0 to n minus 1, 0, 3 minus 1, 0, and either you have to put it here 2, or because there is a place for one number here, so you have to, because this formula tells us 0 up to n minus 1, so you have to place another number here. So it is 0, 1 and 2. The 0 is S orbital, 1 is P and 2 is D. Which orbitals they are? Now we are talking about the third shell, so it is 3s, 3p and 3d. So these are the information which the azimuthal quantum number tells us. So in conclusion, we can say that this azimuthal quantum number tells us that how many shapes are present in the particular shell. There is one shape present in K shell, there, or energy level 1. There are 2 shapes present in energy level 2. There are 3 shapes present in energy level 3, that is S, P and D. How many P's, how many S will that information will be given by the magnetic quantum number. Thank you very much.